Hello again. Continuing our discussion on special products of binomials. We've seen so far this kind of product. Remember, I called these twins. We had x plus a number and x plus the same number. We also saw in part 2 these kinds of twins where they're x minus a number and x minus the same number. And today we're going to learn about these kinds of twins. I like to call these fraternal twins. They're not identical twins like these here, where I have the same exact binomial. So let's review these a little bit. We had said in part 1 that when we have this kind of identical twins with both of them being pluses, we use a shortcut, and it's squaring the first term, squaring the last term, which is our last term, and then we multiply the first times the second times 2. So that would be x times 3, 3x times 2, 6x. And that's how we found that one. In our second part, we said that when we have identical twins with minuses, we do the same thing. We square the first term, we square the last term, which is a plus 9. And for the middle term, we're going to have a minus. And it's going to be x times 3 times 2. So x times negative 3, negative 3x times 2, negative 6x. And notice the difference between these two is just a little minus sign here for the middle term. When we have identical twins that are plus, we have a plus for our middle term. When we have identical twins that are minus, we have a minus for our middle term. Okay, everything else stays the same. Now we're going to see this kind of product. These are fraternal twins because one of them has a plus, the other one has a minus. Let's do FOIL so we can see a pattern. When I do FOIL, I do the first term times the first term, x squared. Then I do the outer term, which means the first one times the last one. And notice this is x times negative 3. So that's going to give you negative 3x. Be careful with the signs. When I do inner, that means 3 times x, both are positive, so this is going to be plus 3x's. And then I'm going to do the last, which is 3 times negative 3, and that gives you negative 9. So when I collect like terms, negative 3x plus 3x, that's going to give you 0 x's. So what I'm left with is x squared minus 9, and that is your answer because these two terms canceled out and made a 0. So do you see a pattern here? The pattern is that whenever we have fraternal twins, it's going to be the squaring of the first term and the squaring of the second term with a minus in between. That's the pattern. So let's look at it with another problem. Let's say I have x plus 5 times x minus 5. So following this pattern, I know it's the square of the first term, x squared. I know there's going to be a minus, and then I'm going to square the second term, which is 5 squared, which is 25. That's simple. So whenever you have fraternal twins, make sure to follow that pattern. Let's do one more. Let's do x plus 6, x minus 6. We square the first term, and then we write a minus, and then we square the second term, and that's the answer. Now I want you to practice this using this pattern, so go ahead and try these two problems. I want you to hit pause, work on them, and then come back to see the answer. The answer to the first one, notice that I have x minus 7, x plus 7. They're definitely twins, but not identical twins. They're fraternal twins. So I'm going to use this pattern. It's squaring the first term minus squaring the second term, which is 49. And that's it. For this one, the same thing. They are twins, fraternal twins. So I'm going to square the first term minus squaring the second term, 81. And you're done. That's your answer. I hope you got them right. Let's do a couple of more examples. Let's say I have x squared plus 2y times x squared minus 2y. Are these twins? Yes, they are. They are fraternal twins. They have a plus and a minus. Everything else is identical. So I'm going to use the pattern that we saw here. I'm going to square the first term. Now be careful here. When I square x squared, that means taking that first term the way it is and squaring it means raising it to the second power. Whenever you raise a power to another power, we multiply the exponents. So this becomes x to the 2 times 2, which is 4. So squaring the first term gives you x to the 4th power. I know I'm going to have a minus, and then I'm going to square the second term. Here's your second term, 2y. So I'm going to take 2y, and I'm going to square the whole thing. Remember that this power we're going to distribute to each one of the factors. So this becomes 2 squared times y squared. That becomes 4y squared. So that means this is 4y squared. And that is your answer. I'm going to scroll down and I want you to try some problems on your own. Hit pause and then come back. Here are the problems. Here are the answers. These are fraternal twins, so I'm going to square the first term minus the square of the second term, which is 64. When I say square, that means 8 squared, which is 8 times 8, 64. And this is your answer. For the second one, I'm going to square the first term, which is 9, because 3 squared is 9. And I know I have a minus, and then I'm going to square the second term. I'm going to do this over here. 2y squared, this whole thing I'm going to square. So I'm going to distribute the exponent to each one of the factors. 2 squared, right, 2 squared, and then y squared squared, that's raising a power to a power, and we had already said that whenever you raise a power to a power, you have to multiply the exponents. So that would be y to the 4th power. We're also multiplying exponents here. Notice that the power that this 2 has is a 1. So 2 times 1, that gives you 2. 2 times 2, that gives you 4. So it's really raising a power to a power, and that will equal 4y to the 4th power because 2 squared is 4. So this would be 4y to the 4th power, and that is your answer. For the third one, you square the first term, 81, minus, and you square the second term, r squared. Those are your answers. I hope you got them correct. I'll see you in class.